In this video, I'm going to talk about a data set that I collected recently. It could be used to run through different programs for creating models and or 3D visualizations from images. So it's basically a way to interpolate images, create new views from some set of images. Most of the data sets that I see out there are pretty simple in nature in that they have a central object that someone goes around, and while that object may be complex, it's still pretty simple in that it doesn't have a lot of occlusions. So this data set I captured was with an Insta360 1R 1 inch. That's a really wide angle action camera. And I walked around the place with the camera up on a pole and did a few laps around, and then I walked in and through all the different structures. I recorded those videos, and it was a total of 3 videos that overall took about a half an hour to record. From that video I extracted frames once a second, so the original imagery was captured at 24 frames per second at about 100 megabits per second. And as I say, I extracted those frames about once per second. I input those into Agisoft Metashape and did the alignment processing, which gave me a sparse point cloud. I then did an ultra high resolution model, a meshed model, and this is just a colorized model, so no photo texturing has been applied. Anyway, you can see that the imagery covered the whole camp pretty well. It's not perfect, and I'll talk about this later because we'll look at this video later again without the blue camera locations being overlaid. So here's just some information about those 3 videos that show the times that add up to about a half an hour between the 3 videos, what the image size was, and about 100 megabits per second. As I say, I extracted frames from that once per second. We have almost 1,800 images that are all about 5,300 by 3,000 pixels. They're all stored as PNGs. They actually sum up to more data storage than the original videos. This is just one of the single frames. You can see that the typical issues you have. There's some highlights from the sun. When you get to some angles, you can see above the trailer. There's people in the camp, and those people were moving around because I didn't have full access to this space. This is showing that the underside of some of the canopies, so they were imaged both from the top and the bottom. Because they're thin surfaces, that's a problem. Here you can see a person going into the hut on the right side of the image, so people were actually moving things. The door was open during some frames and closed during others. Here's this visualization again. Again, this is not textured, it's just a colorized mesh, so each vertex has a color. You can see that the areas on the top of the trailer have issues. You can see in particular all of the tarps that are used are very thin. That's a challenge for a lot of these algorithms to get such thin structures, and they could possibly have moved a little even during the capture if there was just a little bit of wind. The thin straps, you can see, are not completely rendered. So this is just flying through like a, an FPV kind of flight. Again, that was all just created from a animation by creating a virtual flight path through this 3D meshed model. Here we go through the monkey hut, which is the kitchen area in our camp. You can see car windows aren't rendered very well. Reflections are often a problem for these algorithms. But overall, the complexity of this scene is really, really high. So this should be great to see what other algorithms, such as Gaussian splatting. I've seen some videos people have made on that process, and I suspect that that may do really, really well. Of course, even just with the photogrammetry, if the following step of texturizing the surfaces was done by reprojecting the photos back onto the surfaces, that would improve things, and it also may close some of these holes, particularly in the meshes of this aluminette and the 10 by 10 structures here. Anyway, enjoy. Maybe these can be used by everyone. Thanks.